NetSim Astra is a satellite planning and radio frequency coverage studio. It lets you design a satellite constellation, define the radio link, and see the coverage that results on a real three-dimensional globe. This walkthrough shows how a coverage analysis is set up, run, and exported. The Analysis Configuration section is where the type of study is chosen. Here, Astra provides different analysis options such as point analysis, coverage prediction, and satellite footprint. For this case, we select coverage prediction. We then define the geographical region over which the coverage has to be evaluated. Grid granularity sets how finely that region is sampled. Minimum elevation sets how low a satellite may sit and still count. The computation settings fix how much is worked out. Duration is the span of simulated time. Time step is how far the clock moves between calculations, here 30 seconds. Next, we configure the satellite constellation. Astra provides different options for defining satellites, including synthetic constellations and TLE-based satellites, built from published orbital elements. A single fixed satellite and geostationary satellites can also be defined. For this analysis, we use a synthetic satellite constellation. The required orbital parameters, such as the number of orbital planes, satellites per plane, altitude, inclination, and other constellation parameters, are configured here. We then configure the remaining parameters required for the coverage calculation. This includes the radio frequency and link-related settings, along with the antenna and receiver characteristics. The link band and frequency come first, then the transmitter. After that, the receiver, then the digital link settings. Next, the flux density limits. After that, the antenna pattern. And finally, the propagation losses. Once all the required parameters are entered, we start the coverage prediction. Astra now runs the analysis. The constellation is built, and the satellite positions are propagated across the simulation duration. Then, at each time step, it evaluates the link to every visible satellite over the coverage grid and records the received signal level. Once the computation is complete, the coverage results are displayed on the 3D globe. Here, the selected region of Japan is highlighted with the calculated coverage values. The color scale represents the variation in received signal strength across the region. The satellite positions are shown around the coverage area, moving as simulation time advances. Clicking a point on the map gives the best satellite link for that location, with the serving satellite, the received power, the carrier-to-noise ratio, the elevation angle, and the distance. Click somewhere else, and every one of those numbers changes with the geometry. By moving through different simulation time instances, we can observe how the coverage varies over time. This helps us understand the relationship between the satellite constellation geometry and the resulting signal coverage over the selected region. The whole grid can be taken out of the panel at any point. Open coverage CSV in Excel. Once the analysis is complete, the coverage results can be exported. Astra writes the full coverage grid to a CSV file, 39 columns wide. Each row is one grid point, at one moment in time, for the satellites serving it. The first group is the geometry, where the satellite was and how far away. The second is the result, the received power at each point. Then the power flux density reference level, the regulatory limit, and the margin between them, the carrier-to-noise ratio, the Doppler shift, and the coded bit error rate. It opens directly in Excel.